Hi everyone, and welcome to this final Udacity Deep Reinforcement Learning Nano Degree weekly webinar. So, look, most of you are probably to the point where you would be almost finishing everything. Wait a second, I just need to unplug something. Sorry about that. So I'll start that again. So I just had a feedback loop on the audio. So look, this week we'll be focusing on the final project, which will be collaboration competition, which is basically a tennis, two rackets, trying to bounce it back at each other for as long as they possibly can. And look, it's multi-agent, so you'll be controlling both. And there's many ways that you could, have a look at this sort of issue. So, but look, I'll go into parts of the project. So, what we'll cover, basically just go over again the project instructions, project overview, evaluation, project submission, rubric, where to start, make the project stand out, bit of a code walkthrough, which I'll go through just with the workspace given by Udacity, some environment setups, go to the Git repo, and also then go through just Windows, Mac, Linux, and AWS setups, as well as some extra hints and Q&A. So for this project, you will train an agent to solve a provided environment. To submit the project, you will provide a link to GitHub repo with the implementation. If you'd like to refresh it on the GitHub, please check out the lessons in GitHub and extracurricular content. To review the detailed project requirements, please read the rubric. The format of the project is open-ended and only satisfying the points of the rubric. For instance, we expect that, so basically, you can do it any way you want. You can look at, say, your last project with using DDPG and just basically turn it into an MA DDPG would probably be the simplest method. So if I go into the project rubric and go over that, so basically split into three sections. You've got your training code, you've got your readme section, and your report. So basically, as long as you cover each one of these sections in here and make sure that everything meets the requirements, you'll be absolutely fine. So if we go back, so next, so in this environment, there is two agents that control a racket to bounce a ball over the net. If an agent hits the ball over the net, it receives a reward of 0.1. If the agent lets the ball hit the ground or hit the ball out of bounds, it receives a reward of 0.01. Thus, the goal of each agent is to keep the ball in play. The observation space consists of 8 variables corresponding to the position of velocity of the ball and racket. Each agent receives its own local observation. 2 continuous actions are available, corresponding to movement towards or away from the net and jumping. Solving the environment. Note that your project submission needs to solve one of 2 versions. I didn't update that one, so I just might move that across. Sorry about that. I must have accidentally brought the wrong slide in. Anyway, so the project will be reviewed against the Udacity reviewer, against the project rubric, which we went before. Review this rubric thoroughly and self-evaluate the project before submission. All criteria found in the rubric must meet specifications for you to pass, as you would know from doing the other projects. As described in the rubric, your GitHub should contain the README, code, and a report. So the README basically has to explain how to run the project, any requirements, anything that you may need to do. Code should be have the training the agent along with the training model and weights, and also have it to be well commented. The report describing the learning algorithm, this is where you will describe the details of your implementation along with ideas for future works. Basically, you just need to explain what you've done, go into what you used and why it works and why things didn't work, and maybe go into some different results that you may have got as well. I suggest that you do it through GitHub, but you can zip the file up and send it through, but don't recommend that. And if you do that, it's easier to just get, even if just a free GitHub and set it up, it's good practice anyway. So basically, I would probably start this project using looking at the DDPG and what you used from the last project, and so, which would probably be the easiest to implement an MA DDPG. So have a look through all of those, material, and then study the coding exercises from the DDPG section. So what I would suggest is look at the MA DDPG and what you could do with it, and also go through all the material from the MA, the multi-agent sort of exercises. So pretty much what you want to do is go through all of the multi-agent exercises, read through that, adapt the code from your current DDPG, and try to find a happy medium. And also have a look at other implementations, and references on material on the web, and you should be able to find a good way. If you've done the multi version of the previous project, you'll probably find this one not too difficult. All right, just going to go to the next section. So basically, go through all the other bits and pieces if you want to start, and like I said, go through what you've already done. Now I've got a couple of actual things messed up here. So basically, the optional challenge is, which I've got crawl because I've mixed up the different material here. But the project that you've got to do is with the Collab Compete, you can also do a soccer one, which is great to do. So you've got the tennis environment and then a soccer one if you finish that. So maybe have a look at that as well. Now, workspace installs. Local installs, Windows, Mac, Linux, AWS, and Google Cloud, which I won't go into today. So now, if you go to the repo, which is for Udacity, your project is in here, and here is the basic details of it. So, basically what I've gone through, and this is the extra one that you can do, which is a soccer one that you can do down the track if you finish off this one. So the other thing which I would talk about is in here, it explains, second version is useful. So, oops, that was the wrong one. Didn't quite go to the right space. My slides are a bit mucked up today. I think I've accidentally saved over the wrong thing. Anyway, we'll continue on. So the workspace. Just make sure it's going to the right one. Since having so much. Oh, yeah, yep, that's going to the right one. Sorry guys, it's a bit mixed up today. I must have just messed a couple of the slides up when I was putting it together. All right, so if we look at this, make sure you do the trust, otherwise someone has a bit of a meltdown, I've noticed. So say we start the first line of code, do the pip install, shouldn't take too long. Let's run through the next couple of bits. That's importing the Unity agents and the environment. Now, I recommend training everything once again in CPU mode, but then when you're finished and you've got a working model, definitely use GPU mode for this, for sure DTPG, unless you're trying to use other algorithms. But yeah, either way, I'd use the GPU if you can. Now, this seems to be taking a while today. There it goes. And import brains, clear the brains. And now we're going to have a look at a bit of the information. So you've got 2 agents, as you can see. Size of each action is 2. So, and then there are 2 agents, each observation state with a length of 24. So that's the details. So what I will do as well, actually I'll leave that for now. So if we just let it do a random, it didn't do very well. As you can see, not doing very well at all. That's just pure random luck, basically, at that point. So then what you need to do is put your code in here, which you've done in previously. You shouldn't find this too difficult. I found that by the time you've done the first 2 projects, this may have some bits and pieces that are difficult, but overall it's a pretty good project. So, and good fun, you know, because you can try different things with the rewards, information, how you're going to set that out, and different things with MA, whether you're going to have 2 separate neural policies or 1 policy for both. You know, it's up to you. Each will work, but they all work in slightly different ways. Okay, next is local install. So basically, if you want to install, go to that the Udacity Deep repo and run through this. So do a kind of create new things, clone it, go into the Python, pip install. You might get some errors, then you might have to run that and do a pip install for Unity agents, if that's the case. Then what you pretty much need to do is go to the folder, move to the complete project to the folder, then download the environment, unzip it, move the environment, run the Jupyter Notebook, and run through the cells. Very simple. Linux is even simpler. So basically, go to the repo, create an environment, activate it, git clone the repo, cd into Python, and pip install, and it will just work. That should be absolutely all you need to do to get everything up and running. Basically here, same deal, you create the folder, move the project details, download the Linux environment or the Node Viz, unzip it, move the environment, run the Jupyter Notebook, and off you go. AWS is a little bit more tricky because there's one particular environment that works really well, and I've put that one here, so look at that. When log in, go to the community search, find it, make an X large, P2, open up port 8888, launch the instance, create a key, SSH into it. Now that you're in it, you basically run through this, so do the same deal. Git clone, cd into Python, install it, probably get an error, and if you do pip install Python, you do P3, go into the folder, get the file from Amazon, unzip it, and basically then run the Jupyter Notebook using the IP00 no browse, copy the URL from the terminal and replace it with the external IP, paste in the browser, run the navigation project, and test the cells, and then import torque. Now, this project, I'll talk about a few things. So basically, I've changed the args in OU noise from the DDPG. I've also changed the way the rewards and that are coming in because you've got multi-agent. So you need to, you can either have a neural network where you feed all the details in, which is interesting, and get an overall reward from what it's doing, or you can have separate ones. So, but they do all have different actions that you need to give. So you'll have to code that out. Change or remove the L2, sometimes that can cause weird issues. You can have a go at trying to do MA like with a PPO A2C, but I'm not sure how easy that would be, or even see if it's possible. Change the batch size, you know, and just play around with hyperparameters and everything else, which is part of it. Now, like I said, for some reason my save hasn't come in and hasn't overwritten some of the details, but try use Optuner. So Optuner, I'll do a quick. So Optuner is for hyperparameter optimization. It's something that I've been just starting to get into. So you could probably use this to run through all different hyperparameters. But yeah, definitely have a look at this. This is really cool. It's used a lot in deep learning, but I've just started to play around with it in deep reinforcement learning to run and try different sort of parameter sets and stuff. So mainly I've been doing it with financial markets and you know, trying different sort of parameters. But yeah, if you've got the power to go through, like I've got some data with the Google Cloud Platform that I need to use and credit. So I'm going to probably run a whole batch using Optuner to sort of try the best parameters. For example, you know, retro games, because they do need quite powerful systems to run properly. But look, so look, that's probably it for tonight. You know, it's not very long. It was a little bit you know, all over the place today. But look, I would recommend if you get stuck, contact me, have a chat about things, and you know, I've usually got reference material that can sort of show you where to go and different bits and pieces. So once again, thank you very much for this. This will be my last webinar as your mentor. And, you know, I hope that you've learned a lot and that you've got something out of this. You know, it's been a great journey. I've seen a lot of incredible results from some great engineers and technicians, and developers, and just people that are, you know, wanting to learn this and you know, develop the industry and the field. So, you know, some people are doing it for work, others are doing it because they love it, and others want to become, you know, deep reinforcement learning researchers. So it's a great field to go in. I absolutely love it. What I recommend when you finish this course is create a gym environment from scratch and build and make your own complete environment and just work through all the different things that you've learned, different algorithms, and see what works and what doesn't. Try using some things like stable baselines and other bits and pieces, and you know, hopefully you know, will make a massive difference in, you know, what you can do. So once again, thank you very much, and I guess that will be it for now. All right, so